All right, let's dive into some of the weirdest, most incredible landscapes on the planet. I mean, places that seriously look like they're from another world. They're all sculpted by a force we know really well, water. But this isn't the story you're used to, with powerful rivers carving out canyons. Nope. This is something much quieter, much stranger, and honestly, way cooler. So just look at this. You've got these incredible stand towers, massive underground worlds, and a surface that looks like it's been shot full of holes, any one of which could just swallow a house. How in the world does this happen? What kind of invisible artist is at work here, carving solid rock not with brute force but with chemistry? Well, let's find out. It turns out these totally bizarre, alien-looking places actually have a name, and that name comes from a very specific spot on Earth where this kind of landscape is just legendary. It's called Karst topography. The name itself comes from the Karst region over in the Balkans, right near the Adriatic Sea, where these features are just everywhere. And the key thing to get is that a karst landscape isn't defined by what's been built up, but by what's been slowly, patiently dissolved and carried away by groundwater. Okay, this is where you really have to shift your thinking. Normally, when we think of erosion, we think of a river acting like a physical force, right? Like sandpaper just grinding away at rock. But with karst, that's not what's happening. It's a chemical process. Water isn't a hammer here. It's more like a quiet, persistent solvent, just dissolving away soluble rock like limestone, molecule by molecule, over thousands and thousands of years. So, what's the magic recipe to create one of these incredible karst landscapes? Well, it turns out you need a very specific set of ingredients, where the rock and the water come together in just the right way. Okay, so ingredient number one, you need the right kind of rock. We're talking about something rich in calcium carbonate, like limestone or dolomite, that water can actually dissolve. Second, that rock can't be a solid, perfect slab. It has to be permeable, full of little cracks and joints that give the water a way to get inside. And finally, of course, you need lots of water on the surface, ready to start its journey seeping down into the ground. So let's follow a single drop of rain as it starts this whole process. This is where the real sculpting begins, right there at the surface, as that water starts to work its way into the ground. The very first feature that forms is something called a swallow hole. It's really just a small, shallow little dip where water can pool up and begin its chemical attack, dissolving the limestone and creating the first tiny entryway into the rock below. You can think of it as the first little pinprick in a giant block of stone. And from that tiny swallow hole, we get the most famous karst feature of all, the sinkhole, specifically what's called a solution sinkhole. The process is actually pretty straightforward. Water trickles down through those cracks. It starts dissolving the rock just under the surface, and as that hidden void gets bigger, the ground above it just kind of slowly slumps down, creating that classic funnel shape we all recognize. And the scale we're talking about here is just staggering. A sinkhole can be a little dip in a farmer's field, or it can be a massive chasm, a whole hectare wide and over 30 meters deep. It all just depends on how long that quiet, invisible dissolving process has been going on. But once the water is deep underground, its journey takes a turn. It's not just about going down anymore. Now it starts moving sideways, looking for the easiest path forward. And this is a really important moment in the story. After seeping straight down, the water eventually hits a layer of rock that's harder to get through. So what does it do? It changes direction. It starts to flow horizontally, following the natural layers in the rock, what geologists call bedding planes. And this horizontal flow, well, that is how caves are born. As the water moves along these bedding planes, it just keeps dissolving the limestone, carving out these long, narrow gaps that, over thousands or millions of years, grow into the enormous underground networks we love to explore. Oh, and if a cave happens to break through to the surface at both ends, we just call it a tunnel. And we're not just talking about one simple tube. A single karst region can be completely riddled with a complex maze of caves at all different levels, kind of like a giant underground apartment building. It's a hidden, three-dimensional world carved out right beneath our feet. But that secret underground world, it doesn't always stay a secret. Sometimes it makes its presence known on the surface in a very, very dramatic way. This brings us to a totally different kind of sinkhole, the collapse sink. We talked about solution sinks, right? The ones that form slowly from the top down. Well, collapse sinks are the exact opposite. They form from the bottom up. It happens when the roof of a hidden underground cave gets so thin that it just can't hold the weight above it anymore, and the whole thing suddenly gives way. And what's really terrifying is that these collapsings can be completely hidden. They might just look like a shallow little puddle of water on the ground, but underneath, there's nothing but air. The source material has this perfect, chilling line, saying anyone who steps into one would go down like it happens in quicksands, just a sudden, shocking disappearance. Now, over time, as more and more of these sinkholes form right next to each other, their walls can start to slump and collapse, and they actually merge together. This creates an even bigger feature called a uvula, or a valley sink. It's basically a long, wide trench that shows you exactly where the most intense underground erosion is happening. So, after thousands, maybe millions of years of this, of sinking, dissolving, collapsing, and merging, what in the world is actually left on the surface? You get this. It's called a lapi. This is what's left behind when most of the surface limestone has been completely eaten away by all those pits and trenches. It is an unbelievably irregular landscape, just a maze of sharp points, deep grooves, and jagged ridges. It's practically impossible to walk across. But the story doesn't even stop there. With enough time and enough erosion, even that jagged, gnarly lappy fields can be worn down even further, eventually becoming a smoother, flatter, though still deeply cracked, surface that we call a limestone pavement. So let's just quickly recap the whole journey, right? It all kicks off with a simple swallow hole. That grows into sinkholes, both the slow solution kind and the sudden collapse kind. Those can merge to form huge uvalas. All the while, underground, water is carving out caves and tunnels. And what's left on the surface is that rugged lapier terrain, which can finally smooth out into a limestone pavement. It's an entire world, all sculpted by the quiet power of dissolving water. Which really leaves you with one final, pretty amazing thought. This whole process, it's not just ancient history. It is happening right now, silently, invisibly, all over the world. In every region with limestone, water is seeping down, dissolving rock, and carving out the landscapes of the future. It really makes you wonder, doesn't it? Right now, beneath our own feet, what hidden worlds is water carving out at this very moment?